Good afternoon. It's me, Savitri, again, and we are going to discuss the topic 8 and HBMS 3303. It's digital music technology and topic 8. Okay. So what is digital learning and why and how it is useful for a teacher? I said to explain the production in the learning outcomes. We talk of a production of digital and analog sounds of music, and we discuss the role of technology in everyday life, education and music. And also we describe the basics of computers, operating systems, major software applications, and also the software and hardware of a computer. First of all, when we talk of the introduction to sound and sound production, we know how sound is created. When sound is produced, when two materials are rubbed, vibrated, collided, plucked, blown and knocked. And in an audio production of a presentation, the sound is produced as a result of vibrations from playing a musical instrument or the vibration of the human voice. And when we talk of vibrations, each round of vibration is called hertz, and also the intensity of the resulting sound is called amplitude. So the sound, the loudness is the intensity is called the amplitude. And when using both ears, hearing is using both our ears, it's called binaural, because we hear it with two ears, and it is measured in decibel units, dB. And when you look at and when you hear, you see both our ears have time differences for the sound to reach them. Sound doesn't reach both the ears at the same time. And this time difference sound that reaches the left and right ear is called the Haas effect, or we call it the precedence effect. So we don't hear a sound from both ears at the same time, and it's interesting. And also when we listen, there are two conditions. How do we listen? We listen analytically and also critically. What is analytical listening? It's a process of evaluating the content and functions of music, while listening critically is a process of listening in terms of sound, character, and technical quality. So there is a difference between analytical and critical listening. And also we say the human ability to hear in frequency is from 20 Hertz to 20 kilohertz, and the sound pressure strength is 0 to 120 dB and SPL. So the ability to hear, the frequency, it's 20 Hertz to 20 kilohertz, and the sound pressure is 20 to 120 dB. Now we talk of digitalized or digitized sounds. What is digitized sound? Digital sound has proved to be far superior than the analog sound. So there is digital and analog. So digital is far more superior, as that sounding is better. And you see, you can record and convert analog sounds in digital form from a microphone using a tape recorder and cassette through the converter. So through we record analog sounds through a converter, we can turn it into digital recorder, and it is known as an ADC, that is analog digital converter. Then and play the digital sound back to analog sounds using a DAC, that is a digital analog converter. So we can use an analog digital converter, and also to turn the digital sound back to analog, we can use a DAC, that is a digital analog converter. And now here we have a variety of formats, how digital sounds can be saved. So we have these formats. We can save it in the wave format and in MPEG level 3, that is MP3 normally we see, and then we have the sound, and then we have real audio or real media, that is reported or WAN, and audio interchange file, that is called audio interchange file format. So all this is how the digital sounds can be saved. And then we have the standard QuickTime movie. It's often used for audio file storage capabilities. So, and we store it as QuickTime files, and it's used in most of the computers. So in either the Windows or the Mac OSs, we have this kind of QuickTime files, that is to save the digital sounds. And then we talk about what is the benefit of digital sound over analog. When you record it in a digital sound, there is no wind sound or hiss, there is no disturbance. The quality of the recording is similar to the actual sound without compromising the quality of the original sound, and it is real like the original sound without any disturbances. And it says it's easy to edit and balance the sounds, and also it helps the users to use the data with high speed. And also it says users are able to speed up sound with video or other media with an accuracy of 20 microseconds. So that is very quick, 20 microseconds. So these are the benefits. And now we talk about the functions of technology. Right. So as the teachers, we should have a bit of knowledge on technology. So because now when we talk of music, how are we going to record this music, and how are we going to record it analogically or as in the digital way, and what are the softwares that is there. So the technology is important here. So here we say the use of this technology encompasses all aspects of human culture in the world today. So what do we need technology for? We say among the roles of technology covered in this module, we talk of the role technology in the daily life and technology in education, and here the role of the music for the purpose of appreciation and creation. So technology in daily life, in education, and in music for appreciation and creation, creating of music and appreciation of music. So technology is important. In daily life, there are three types of computer networks, and we talk of transmitting data over the telephone lines or microwave. That's how we're talking of transmitting data. We have what we call the local area network, the LAN, metropolitan area network, MAN, and wide area network, WAN. So I think all of us are somewhat familiar with all these when we are using our internet connections. We say the LAN connection, the WAN connection, like that. And in education, it serves the computer technology serves as a tutor, it serves as a tool and a tutee. So that means it teaches us, we use it as a tool, and it also we can teach through the computer. And combination of computers with telecommunication technology has resulted in information communication and technologies. When we talk of ICT, that means a combination of telecommunication and information communication, which is very much needed in education today. And it serves as a basis for a strong information processing, information transporting and distributing information in various forms. So that helps us in processing information, storing information, and transporting and distribution of information. And more details are given in your module. Please refer to page 127 and 128. And now we talk of music, how and why we use technology for appreciation and creation. And since the 1970s, computers have been used by the music activists for the purpose of appreciation and creation. And in the music industry, there are certain operating systems used in a computer, and the main software is Windows and Mac OS, and we call the application softwares. The software is divided into several main sections when we talk of application of software. So these are the application softwares we are talking of. Number A is notation software. What can it do? This software can copy song scores, make song arrangements, and print scores in a standard notation. And among others, the softwares are Score Writer, Encore, Sibelius, and Finale. So these are the types of softwares that are there. So why do we need this? That is, it helps us to copy songs scores, that means the notes, make arrangements, change the different beats, change, add or delete or do anything, and then also print the music notes in standard notation. And the softwares that can be used is for Score Writer, then we have Encore, Sibelius, and Finale. So these are the type of softwares that are there, the notation softwares. Then we have the sequencer software that is capable of producing musical arrangements by applying plugins software, syntax sounds, multi-track recording, applying sound effects, making sound effects according to video action, and so on. You can see what a lot technology can do to sequence music. It can produce musical arrangements, then turn multi-track recordings, applying sound effects, making sound effects according to video actions, and so on. And among those softwares are Pro Tools, what you call the Cubase, Nuendo, and Sona. All these are softwares that can be used for these different purposes. So these are sequencer software. Earlier it was a notation software where we have the Score Writer, Encore, Sibelius, and the Finale. So those are some of the softwares for notation software. And here for sequencer software are Pro Tools, Cubase, Nuendo, and Sona. Then we have interactive software, and this type of software, what does it do is to enhance public knowledge of music, music appreciation, oral ability, and music theory. So that is also a software which helps to enhance the public knowledge of music and to appreciate music. Oral ability, that means for better hearing, and also for music theory. And the software is we have what we call Aurelia. So different types of software. Then now we talk of the computer, which we are very much familiar with, and this is just the basic information. You can see 5 parts in computer: information system, and we have the part and the description. We have the human part, then procedure, we have the software, hardware, and data. When we talk of the 5 parts of the computer, first part is human, so that means those who operate the computers like us. Then we have the procedures. So procedure is the rules to be followed by humans. And then the software, we have the software which is the programs where the instructions to the computers perform tasks, and how what we do, how can we work with these computers using the software. We have different softwares for different purposes. And you have the hardware, that is the equipment that controls the software, and it is the data processing, where we have the input devices, output devices, all those kind of things. And then we have the data, so that is the raw facts that have not been processed. So that is the text, numbers, images, audio information, and all that. So these are the 5 most important 5 parts in a computer information system. This is basic introduction to computer. And now we have the types of computers. We have the supercomputers, where those are used by like for example the NASA, and for exploration of space, those are the supercomputers. And then the mainframe computers that are used by large organizations, the mini computers like the mid-range computers, and the microcomputers which are used by all of us and which have experienced growth and undergo rapid changes, like the desktop, laptops, personal digital assistants, that's the PDAs. So those are the ones that we are using. So these are the types of computer. And we have what we call the main components of a computer system and its function. Okay, what do they do? What is there in the computer? We have the system board, microprocessor, memory, system clock, boards and slot pads, what we call the buzz lines, and the port, and also the different functions for each of these. For the system board is where the system components are placed, then the CPU in the microprocessor, and so forth. Yeah. Then we talk of the microcomputer hardware. 4 categories. So 2 are here in this slide. That is the system unit, which is the electronic circuit, and we have the input and output devices, which is the keyboard, mouse, scanner, images, camera, touch screen, barcode, and all that type of thing. And we have this barcode readers, optical mark recognitions, and many more. These are the 2 here, the system unit and the input and output device. And we have software. Yeah, the data service serves to explain something and is usually stored electronically. And then the software program is designed to carry out instructions to the computer on how to process data in the form that we want. Then we have 2 main types of software. What are those 2 main types of software? We have the system software and the application software. The software is also known as the operating system, such as Windows, Vista, Windows XP. Those are the system software. And then the application software is assigned to carry out the work for general tasks, like the word processing or data analysis. What are operation systems? Then, as we said earlier, operating systems support multitask or ability to carry out more than one application at a time. That is multitasking. And then we have what are the systems? Those are the Windows XP and Vista, Mac, and the Linux. And multimedia. Now talking of multimedia, what are the advantages of using multimedia in teaching and learning? It is really important for us as teachers. What are they? Students are able to learn on their own and revise at any time, and multimedia increases students' interest rather than just the teacher teaching in the class. If we have interactive multimedia, the students are very much interested. And also material development costs are cheap and simple. We can access so much of material online, and rather than just finding out from books, and it is so quick and it is simple. And also the increase of understanding and information retention. It increases the understanding and information retention rather than the teacher teaching on the blackboard or the whiteboard. If we have these multimedia processors like the interactive whiteboard, internet connections in the class, so it's easy for the students to understand and also for the retention of the information. Then we have 5 elements in the development of multimedia program. This is say the elements, and it is detailed in page 135 to 138 in your module. So what are the elements? We have the texts, we have the graphics, we have the audio, video and animation. When we talk for multimedia programs, so these are the the 5 key elements: the text, the writing, the graphics, the pictures, then the audio, what you hear, videos, and also the animation, how we change and how everything is made exciting through animation. Just read page 135 to 138. And the summary. Now, sound is produced when two materials rub, vibrate or collide with each other, and each round of vibration is called the hertz, and resulting sound intensity is called the amplitude. It's measured in decibels, and the time difference between the two ears, the left and the right ear of the listener, is called the Haas effect or precedence effect. And sound is influenced by the characteristics of the wave frequency, velocity, wavelength, amplitude and speed. And we have the wave formats, MPG levels, audio and real media, audio interchange file formats, resource interchange file formats, and then how the sound waves up, digital sound is produced from sound waves, and how it is captured acoustically, and it's generated through the microphone and converted into electrical energy. So this, when we talk of how do we produce digital sounds. And also we're talking of how the results are presented at a specific frequency by digital recorder, and it is through a series of binary, we call it binary digits, that is bit patterns in analog to, when we talk of analog to digital. And then the DAC, we said, switches back from digital to analog. Then the DAC switches back from digital to analog sound because the speaker system and the human ear can only receive analog sounds. So we can't, that is why the digital is again changed into analog when it goes into our ear. And technology plays an important role in our lives, education and music. And we talked of notation software that can copy songs, make song arrangements and print scores in a standard notation. That should be really studied by us as teachers, how we can use the notation software. And the software that can be downloaded and used are Score Writer, Encore, Sibelius and Finale. Thank you.